I'm Bill from Iron Will, and in this episode we're going to talk about energy and momentum and how they apply to bow hunting. You might hear that energy doesn't matter, it's all about momentum, or vice versa, and really they're both very useful to look at to understand what's happening, what we can do to improve things in bow hunting. So momentum is just mass times velocity, which is mass in motion. Kinetic energy is the ability of that mass in motion to do work, where work is a force times a distance. So it's the ability of, say, that arrow to do work at the target. Let's talk about energy first. So kinetic energy is 1/2 mv squared. Work is force times distance. So at the bow, your bow is doing this. You have a draw force curve where as you draw it back, you have a certain force at each position, and that's constant in your bow. So your bow is really kind of a constant energy machine. It's going to put out the same amount of energy no matter what the arrow is, because it's really just this force times distance. And you can see what you can do there. If you can increase the bow poundage, say 10%, you'll get 10% more work, 10% more energy coming out of the bow. So you can see how there's that improvement there. Or if your draw length's longer, you'll get that improvement as well. On this side, kinetic energy, there's also some energy losses due to noise, vibration, or friction, but they're fairly small. This is basically what the bow is doing. 1/2 mv squared, this is the kinetic energy as it leaves your bow, and what we want to do is maintain the most kinetic energy we can have downrange. And so in general, I'll say choose mass over velocity, because the mass won't change, but the velocity will decrease downrange because of the force, because of the drag force, will cause some deceleration. And drag force is proportional to velocity squared. So if you have a light, fast-moving arrow, it will decelerate, it will slow down more, you'll lose more momentum at the target. So you can improve your total energy downrange by choosing mass, more mass over velocity. How much mass? I say make it as heavy as you can for the trajectory you want. And that will depend on your setup. For me, that's about 500 grains. Typically, I recommend 450 to 550 grains for hunting arrow setups for North American big game. I think that's a good balance, personally, of enough mass momentum, but still good trajectory. Once you hit the target, this is kind of happening in reverse. Whatever kinetic energy you have left is going to apply a force over distance to that arrow. And if you can reduce the force to penetrate, if your broadhead design, say, is very sharp, retains the edges, and has a low force to penetrate, if you can cut that force in half, you will go twice as far. So there's a 1-to-1 improvement by reducing force. So you can see from this that broadhead force can be a big factor in penetration. One other thing I'll say is that as you increase mass, your bow becomes a little more efficient. So just from the bow itself, you'll have maybe 3 to 5% more energy as you have higher mass as well. As we take a look at momentum, the equation there is that force over time will be equal to mass times change in velocity, or change in momentum. And momentum is a vector quantity, meaning it's in a straight line. So the way you can optimize this is that your bow, you want the force to be in a straight line on the arrow. So what that means is your bow is tuned. And what that means is the nock is traveling in a straight line towards your rest. So your arrow is being pushed in a straight line. That will give you the most momentum, because again, this is a vector quantity, it's in a straight line. So the most you can push that arrow, the more you can push that arrow in a straight line, the more momentum you will get. If it's out of tune and is kicking the arrow around sideways, you can see that a lot of this momentum then is not in a straight line, it's going side to side. Or if you have, if you're under spine and there's a lot of flex to the arrow, you will also have a loss of momentum. So having a well-tuned bow, having a correctly spined arrow will optimize the momentum. Then downrange, again, having more mass versus velocity will retain more momentum, because the velocity will drop due to drag. And then at the target, whatever momentum you have left, this retained momentum will now apply a force over some time to the arrow. So again, cutting the force in half could double the time at which that arrow is going to travel through the animal. So that's energy momentum. Stay tuned to our other episodes of the Science of Bow Hunting.